This lesson, we're going to be looking at reflections as a form of transformation. We're going to focus on identifying a reflection and drawing the image of a shape that is reflected, and creating and analyzing designs made with reflections. The outcomes we're going to cover are: explain the relationship between reflections and lines or planes of symmetry, identify and describe the applications of transformations in construction, industrial, commercial, domestic, and artistic contexts, and solve a contextual problem that involves transformations. So we're going to start off explaining what exactly a reflection is. A reflection is a transformation in which an object is shown as its mirror image over a line of reflection. In the past, you may have used mirrors, those red plastic objects that you place on a line, and when you look through it, you can see what looks like a mirror image in the line. That would be a reflection. Of course, looking in a mirror would be a reflection as well. So a reflection is a mirror image. Your line of reflection is a line that an object is reflected over, and the corresponding points on both sides of the line are the same distance away from that line at all times. You'll notice here in this light blue object, it's kind of a funny shape. This point right here is 1 unit above my line of reflection. Well, its reflected image, the point is right here, and that is 1 unit below. This point right here is 2 units above my line of reflection. Meanwhile, this point right here, which is its reflection, the image of its reflection, is going to be 1, 2 units below the line of reflection. So if you think about when you look in a mirror, when you move your hand closer to the mirror or pull your hand further away from the mirror, your mirror image is going to move the exact same motion. So however far away you are from the mirror, your hand in the mirror is going to be twice as far away. Right? So it doesn't matter how close or how far away your hand is, the distance between your hand and your image is always going to be twice as far as it is from your hand to the actual mirror itself. So we're going to look at an example here for drawing a reflection. Joe is creating a stained glass window. He wants the left side he wants the left side to be a reflection of the right side. One of the shapes in the window is the dark green quadrilateral shown, which we can see right here. Draw the reflection of the dark green quadrilateral over the line of reflection R. Now, in this example, we call it a line of reflection. You might also hear the term axes of reflection. It's another term that's often used, but here is my line of reflection right here. That's R. So what we want is for our green quadrilateral to be a mirror image on the other side to the left of that line of reflection. So we're going to start by drawing the quadrilateral on a coordinate grid. Here we go right here. So we have our points E, F, G, and H, and we've drawn in the line of reflection R. We'll notice that point E is 1 unit to the right of my line of reflection. So the image of point E, which would be E prime, is going to have to be 1 unit to the left. Right? So if point D is 1 unit to the right of the line R, point D is going to be 1 point to the left of the line R. So here we got point D, and the distance here is 1 unit. And we have E prime right here, and the distance is 1 unit as well. And we're going to complete the image by doing the exact same thing. Point F, for every other point that is. Point F is 1, 2, 3, 4 units away to the right of my line of reflection. So point F prime is 1, 2, 3, 4 units to the left of my line of reflection. G is 6 units. We can see that it would be 1, 2, 3, 4, 5, 6 units to the right. So G prime, its image is 1, 2, 3, 4, 5, 6 units to the left. And we can see we already checked point E and E prime. H and H prime will be the same distance away from our line of reflection as well. So every point and its image are an equal distance from that line of reflection, but of course they're on opposite sides of the line. So any reflection is always going to be the same distance from whatever the reflected line is, the line of reflection is, that is, and they're also going to be on opposite sides. So we're going to look at a couple of questions here. Which of the following is a reflection or are reflections? So that means there could be one, it could be none, it could be more than one. So if I look at A, I have a point right here, and it is a short distance. We're going to say it's 1 unit away from my line of reflection. The corresponding point on the image that's created is going to be right here, and that is also approximately 1 unit away. This point right here has a corresponding point all the way down here. And the distance from this point to my line of reflection is going to be the same as the distance here to my line of reflection. So they are exactly the same again. Finally, this point right here is about 1 unit away, and its reflected image, or its image point right here, is also about 1 unit away. So yes, this is a reflection. Okay, so that one is a reflection. If I look at my second picture here, if I have this point right here, and we're going to say it's approximately 1 unit away from my line of reflection, where is the corresponding point in the image? The corresponding point in the image would probably be this point right here. This is clearly not the same distance away. So in this case, this would not be a reflection from the original pentagon to the image. For the last picture in C here, I have a potential line of reflection right here, the purple line. And I have the word Tom on the left. And you notice that my M is the closest to my line of reflection. And this part of my M right here, I can find that exact same point approximately right here on the other end. The furthest from the line of reflection in my original is the T, and here is the end of the T right here. Well, that end of the T in the image can likely be found right here. We can say that it's found there. So Tom and M-O-T, Moss, I guess, they would be considered reflections because the word is completely reversed in its order. And the letters, although it's really hard to tell, the letters could be considered to be flipped around as well. Okay, so to summarize this lesson, a reflection is simply a mirror image of an object. You have a mirror plane, or mirror line, or a line of reflection, or sometimes referred to as an axis of reflection. Okay, and your image is going to be the exact same as the original object, but completely flipped around. No different than you looking in a mirror. All points in the image of a reflection are equidistant. It means they're the same distance away from the line of reflection as the object. Okay, so they're all the points in the image of a reflection are equidistant, and they're also on opposite sides of the line of reflection. So if all of your points are to the left of your line of reflection in your object, all of your points in your image should be to the right. If all of them are above your line of reflection in the object, your image should have all the points below. And the distance from corresponding points in your image and your reflection should be exactly the same distance away from that line of reflection.